I feel like you usually say that. Okay. Anyways, this is your review. I'm going to go over some of them. Just remember in class, if you were there, I told you this, you don't have to do those problems. And you don't need to do these problems, okay? But everything else you should do, okay? A heads up, switching forms is really useful if you don't have a graphing calculator. If you know how to do your problems with a graphing calculator, then I would not worry so much with these. Even if you don't have a graphing calculator, these types of problems won't be on the test, but they may help you find answers. Like, for example, if you had a problem that talked about, I don't know, somebody throwing a ball, and this is the equation that represents the problem, and they want to ask what is the vertex, you may want to switch it into vertex form so you can find the vertex. Or if they ask, at what time does the ball hit the ground, you could switch this into intercept form and you'd be able to find the x-intercepts where it hits the ball, okay, something like that. Other than that, you won't really need to switch forms. So again, if you have a graphing calculator, you'll be just using your graph and coming up with your answers that way. If not, you may want to use that, you may not, okay? So don't focus on problems 1 through 13, but it'll be graded, okay? But make sure you have the other ones done perhaps first. That would be great. But I'm going to go and do an example of how you would answer this question. Okay, write it in intercept form. So here you would need to factor. Take out the greatest common factor first, which is a -1. Would take that out. Plus 4x plus 3. You would do glasses. Okay, multiply the first term and last term. That's what glasses is. That's what I call them. 3x squared. And they multiply to give us 3 and add to give us 4. So the only way we can do that is 1x plus 3x. Okay. And since a equals 1, which would be like right here, you can use the shortcut. So y equals negative, make our 2 parentheses, x plus 1 and x plus 3. Okay, you plug those straight in like that. Okay, you don't switch signs or anything. It just is the way it is. Okay. Okay, if you were to do this problem, you can also just graph it in your graphing calculator. You would find your 2 x-intercepts, and you would plug those in for your P and Q, and then you'd realize that A is -1, and you would keep it there as a negative, okay? All right, having it in vertex form, and switching it to standard form, and then standard form to intercept form. You won't really have that on the test, but if you needed to have it in intercept form, I would graph it, find your x-intercepts, and you would plug those in, something like y equals, you'd still have a equals b, and x minus p and x minus q. You'd look at your graph and find what P and Q are, and you'd plug those in. Okay. If you didn't have a graphing calculator, you would need to distribute, and then you would need to factor. Okay. Write this in vertex form and identify the vertex. I feel like once you have this done, you don't have to really worry about that as much because you can find it really easy. Okay. Here I would graph, if you can, and you would do second trace, and you'd choose maximum or minimum, depending on if here it's A is positive, so it would be like a concave up, so you'd be looking for a minimum. And that would give you your vertex, your h and k, and you would plug that into y equals a x minus h squared plus k, okay, and then your a is what's in front of your x squared, which is just 1, okay? If you didn't have a graphing calculator, you would need to find the vertex, and the way I would suggest doing it, rather than completing the square, I would use axis of symmetry equation, which is x equals negative b over 2a. So this problem, that would be a negative 6, which is a positive 6. Okay, so that would be positive 6 all over 2 times 1. That gives us 3. Our axis of symmetry is 3. And then for our vertex, that is 3 comma something. And you would take that 3 and you would plug it into your equation for your x's, and you would get your y value. Okay, so that'd be like 3 squared minus 6 times 3 plus 8. That's 9 minus 18 plus 8. And that should give you 1. Okay, and then you'd plug those into your h and your k. And again, you know a is 1, so your final equation would be y equals x minus 3 squared plus 1. Okay? All right, so that's why I crossed off all of these even ones, because it's not as useful for your test. Okay? Okay. So, this onward is very important. Make sure you know how to do these problems. You may want to review these types of problems from your notes or your homework. Okay? You will need to make sure you know by memory your x-intercept equation. If you did not remember how to do it for last unit, you for sure should know how to do this, okay? So this is our intercept form. For the test, there will be 3 or 4 of either this type of equation with x-intercepts or these types where we have vertex. So make sure you know how to do these, okay? So here, if they give you x-intercepts, you have P and Q will always be your x value for your x-intercepts, and they will always give you a point that will be your x and y. So here we have y equals a x minus p, which is 0, and then x minus q, which is 2. You don't have to worry about switching signs because it's taken care of in your equation, okay? Here we have a positive 2, we plug it in, now it's a minus 2. Okay, it takes care of itself. All right, so now we plugged in our P and Q, and they also give us a point, X and Y, so we'd want to plug that in. 6 equals A minus 2 minus 0, and negative 2 minus 2. 6 equals A would simplify. That gives us negative 2 times a negative 4. Simplify some more. That gives us a positive 8. Okay, and remember that all of these are being multiplied together. Okay, I don't draw those, it's just implied. Okay, so if you want to get a by yourself, you need to divide both sides by 8. You don't subtract 8, you divide. Okay, and you get a equals 6/8, which is the same thing as 3/4. You're not done yet. You will need to plug a into your equation to get your final equation. Y equals 3/4 x, you don't need to have the minus 0, x minus 2. Okay, so whether or not you're using your graphing calculator, you won't need to use your graphing calculator, okay? You'll need to solve it by plugging it into the right form. Plug your p and q in, and they'll give you an x and a y, or another point, and you'll plug that in for your x and y, solve for a, and then plug it back into your equation, okay? These are the same, okay? And it will be very similar on the test. Okay, vertex form. If we are given vertex, we need to know what the vertex form is. You'll need to make sure you have it memorized. Okay, for our vertex, this is our H, this is our K. You will plug it in. You don't have to worry about signs. It will take care of itself. Y equals a x minus 1 squared plus, we do have plus a negative 2. That is the same thing as a minus 2. Subtract 2, okay? All right. They give us a point. That will be our x and our y. Point. You get 16 equals a 0 minus 1 squared minus 2. Okay. First thing you'll want to do is add 2 to both sides. 18 equals a. This is the same thing as negative 1 squared, which is the same thing as 1. So you could put 1 here if you wanted to. It won't change your answer. If you divided both sides by 1, that would cancel, and 18 divided by 1 is 18. So a equals 18. We'll take that and we will plug that in to our a value. Y equals 18 x minus 1 squared minus 2. Okay? Memorize, understand how to do this. Okay? So basically, let's take an example of this. Let's see if I can do this really quick, okay? Say they give us a vertex, and you wanted to plug that into your, let's see, sorry about that. Something like this, cancel that, delete, okay? And you want to plug that into an equation. So this is basically already y equals, and we're going to plug in the other stuff. Let's assume, if you assume that a equals 1, yeah, this is not working very well. The equation, the vertex x minus 1 squared minus 2, x minus 1 squared, x minus 1, x, let's delete. This is Desmos. This is where it's really nice if you want to make graphs and print them. It's really nice. So if you say a equals 1, we don't know what it is because that's what we're going to solve for, and we end up finding that it's 18. But if you don't solve for a, it would look something like this. X minus 1 squared, and then x minus 1, what was it? X minus 1, and then minus 2. Minus 2. Okay, so if you tried to do this with your graphing calculator and you didn't know what a is, you would have the right, see, I'll zoom in, okay? We have the right point, but, which is 1 comma negative 2, and that's what they told you, but we don't know what the growth pattern is. We don't know what a is. And so we don't know really anything else about the equation except the point. If you put in, if they do give you a point, then it fixes for example, the other point was what? 0.16. 0.16. So 0, did I say 0.16? It's 0.16, 0, 16. 0.16 is like right here. Okay, I'll make a point. 0.16. And I think you need to have it in a parenthesis. Okay. All right, so there's our point. Okay. But we need to make sure that that is on the right spot. Okay. If you don't plug in your point and solve for A, your graph is wrong. So here, back here, if we wanted to make it what it actually is 18, then it matches where it's supposed to be. So giving that 1 point helps us to make sure that we have it where it's supposed to be. Okay. Okay, anyways, hopefully, I don't know if that helped or not, or if it just confused you. If it did, just ignore that, okay? So either way, vertex, they give you vertex, that's your H and K. You memorized what the vertex form is. We plug H and K in. We still don't have A, so we need to plug in another point for our Y and our X. Okay? And you solve for A, you plug that back into your equation. Okay? I got to do this really quick because they're going to come in vacuum my room. Okay? All right, so let's go over some of these problems. I'll do maybe 2 of them. Okay? Some of them are kind of, I'm sorry, sometimes the equations are a little confusing. A lot of it you just have to kind of think about it really hard. Okay? I can't really help you on the test. Not really, I can't help you on the test. But if something needs to be clarified, let me know. I can try and clarify, but I can't help you how to do the test, okay? So here, we'd want to start by doing a picture, okay? Always start with a picture. So it's basically the scariest swing sits at 1,300 feet above the Colorado River, okay? So here's the cliff. This is a person. He is sitting on this swing, okay? And, okay, maybe that's where it's up, left up at this height where he is, which is 1,300 feet, okay? The rope is 100 feet long, okay? And, oh, I kind of skipped that. And it takes 13 or 30 seconds to get to the other side. So here we're doing time. This is not distance. So when I draw this person who's sitting on a swing, who's going to go on this parabola, and it's going to come over here where it's 30 seconds. Remember, this is height, and this is time. The graph still kind of, I mean, it looks like the path of someone who is swinging. You could consider this maybe be distance. You may think that's what it is, but we're talking about time. And the graph looks, kind of the same. Okay? The swing is 100 feet in length. So here, this length here is 100. You could say that this as well, from here to here is 100, which means that the minimum height is going to be 1,200 feet. Okay, this would be your minimum. And your time will always be halfway, so this would be 15 seconds. Okay, so do your best. I know it's confusing sometimes. Hopefully the ones on the test are more clear. Okay, what is the y-intercept in this situation? Y-intercept. This is our y, okay? Our y-intercept is going to be 0. Time would be 0. Your height would be 1,300 feet, okay? What is the vertex in this situation? Well, it would be this minimum point, which would be time would be 15 seconds, comma, The height would be 1,200 feet. And write an equation that could model this function. So, once we know what the vertex is, this is our point. Other points are not. These are not x-intercepts. Not x-intercepts. This is not. This graph never even will never cross the x-axis. So for this problem, you have to use vertex form. So y equals a x minus h squared plus k. We plug in our vertex. Our vertex is what we have in B, so we plug that in. Y equals a x minus 15 squared plus 1,200, okay? And then we do have another point that we can plug in. This would be our y and x, or sorry, x and y backwards. 1,300 equals a 0 minus 15 squared plus 1,200, and then you would need to solve for a. So subtract 1,200. Sorry, I'm trying to go fast so the vacuum lady doesn't come. Okay, that gives us 100 equals a, and this would be 15 squared. Okay, 15 squared is 225. So I'm just going to come over here. 100 equals a times 225. Divide both sides by that. Okay, you could simplify that. I like to put it in my calculator and change it to a fraction. A equals 4/9. So your final equation would be y equals 4/9 x minus 15 squared plus 1,200. Okay. All right, and then I was going to maybe go over one of these. I think I'll just walk you through it. Okay, draw the picture. A diver is jumping from a platform. Usually it has like these steps to get up to the top. I'm doing it really a crude representation, okay? This is where he jumps. This would be your height. This is your time, okay? And when he jumps, since this is time, again, this isn't like, usually a diver would dive like this and go straight down, something like that, okay? But when you do it with time, we're doing height over time, so he kind of jumps or whatever, and it will come to finally hits the ground at this time, okay? So, remember, if it's in intercept form, this gives us our initial height, our y-intercept. I don't know if they're going to ask for this, but you would graph this whole thing in here. What is the maximum height? Or when this is going to be a time. You could also say at what time will the diver hit the maximum height? So, and also they ask what is the maximum height. So here you on your graphing calculator, you plug this into your graph, you do second trace, and you choose maximum. You do left bound, enter, right bound, enter, guess, enter, and it would give you your answer, okay? I'll do that really quick. Okay, so like, all right, you do that and it gives you the time is 0.18749, yada, yada, yada. You just round maybe to 1.9. I like to have hundredths place when you do this, okay, seconds. And then it will also tell you your height. So this would be time, height, or maybe parentheses. What we're talking about, height would be 28.5625, round maybe to 5, oops, go back please. Okay, 28.56, okay. How high will it be at those points? What you're going to do is you'll click trace. at the top, and you would push enter 0.5, enter, which gives you a height of 27 feet. You'd push 1, enter, gives you 18 feet. Okay, and how long will it take for it to splash in the water? You would use second, trace, and 0. Select 0, which is 2. Okay. Maximum, I think, is 4. Okay. All right, you would do that. Second trace, 0, left bound, right bound, and then a guess right between those two bounds. And you would get a time of 1.5235974-ish. You would round maybe to 1.52 seconds. Okay? If you had to do this by hand, how you would do it is the time, that will always be your axis of symmetry. Okay, this is your time. So you would want to use the axis of symmetry equation. So for A, you'd do negative b over 2a. Okay, it would give you 0.19 after you rounded. Okay, and then the maximum height, you would take this answer and you'd plug it into your equation for height. Okay, and you would get 28.56 after you round. Okay, and it may be a little different because we rounded this. Okay, if this is rounded, then this is going to be affected by that. So it may not be exact, but it will be close. Okay, C and C is exactly the same. You're going to find the height by plugging in that time. So 0.5 squared plus 6 times 0.5 plus 28. Same thing when you plug in 1, if you did it for the other problem. Okay, you'd get those two solutions that are up here. Okay, and then how long will it take it to splash in the water? This is probably the harder one. Is the height when it hits the water is 0. So you plug 0 in for h. Okay, and then you would need to, I like to solve, you can do it by factoring if you can do it, or completing the square. I like doing the quadratic equation. X equals, our here for it would be t. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you plug those in, you simplify it, you end up getting two solutions. One will be positive, 1.52, and the other one will be a negative 1, as if the graph went on here and it would be negative. Okay, and we never use negative solutions. Okay, at least in this unit. Okay. All right, so hopefully that helped. Remember, please, if you have any questions, ask me. Come the day of the test, in the morning, come. You could come tomorrow if you watch this video. But again, half of the test is kind of this type of problem where they give x-intercepts or vertex, and you have to solve for A and plug it back in, or word problems where they give you information, you need to draw a picture, what's going on. They may ask for an x-intercept, it may ask for a maximum height, or a vertex, or an axis of symmetry, or an equation. They may want you to write the equation that you would find given that information. They may give you an equation, and you may need to graph it and use your graphing calculator or solve it by hand to find this information. So if you feel good doing this review, you should be fine. Okay, if not, come and talk to me. Okay?